Imagine a world where the sky is a dense, cloudy haze, where the air pressure is a crushing 92 times that of Earth, and where the surface sizzles at temperatures hot enough to melt lead. That's Venus, our neighboring planet, a world wrapped in a thick cloak of carbon dioxide. But what if we could slice that shroud of CO2 in half? What changes might we see on this fiery twin of Earth? First, let's consider the composition of Venus's atmosphere. With carbon dioxide making up a staggering 96.5% of the atmospheric mass, it's no wonder this planet is a pressure cooker. The greenhouse effect is in full force here, trapping heat and baking the surface to an average of 464 degrees Celsius. Now let's entertain the idea of having the CO2 content. What would be the effects? The first effect we'd likely see is temperature moderation. Less carbon dioxide means less heat trapped on the surface. The greenhouse effect would lose some of its strength, and Venus might start to cool down a bit, though it would still remain incredibly hot. Next, we'd see an adjustment in atmospheric pressure. Currently, Venus's surface pressure is like being 900 meters underwater on Earth. Cut the CO2 in half, and we might start to see this pressure ease, though it would still be far from comfortable. With less CO2, we'd also see shifts in the atmospheric composition. Nitrogen, for instance, could become more abundant, changing the dynamics of the atmosphere, and potentially altering weather patterns and cloud formations. And what about Venus's surface, with its plains, volcanoes, and rugged landscapes? Lower temperatures could slow down volcanic activity, while changes in atmospheric pressure might affect erosion and the stability of geological features. Finally, and perhaps most intriguingly, we might wonder about Venus's habitability. Even with halved CO2 levels, Venus would still be a harsh place for humans. The sulfuric acid clouds, lack of water, and intense radiation would still pose formidable barriers to colonization. So, what does this thought experiment tell us? While having CO2 levels might moderate some of Venus's extreme conditions, it would still remain a hostile world. But it also underscores the importance of understanding how atmospheric dynamics work, and how changes to these can have far-reaching consequences, not just on distant Venus, but here on Earth as well. So, next time you look up at the night sky and see Venus twinkling back at you, remember the complex dance of atmospheric elements that shape each and every world in our solar system. Because, who knows? One day we might just need that knowledge to shape worlds of our own.